Hello everyone. So today we will be solving this apartments problem from CSES. This is from sorting and searching section. So here the problem stated that we have some n applicants and we have some m free apartments, and for each applicant we have a desired size for their apartment, and we have to tell how many applicants will get an apartment. Okay. Now, the assignment of the apartment is done via this process. So it says that if the desired size of an applicant is X, he or she will accept any apartment whose size is between X minus K and X plus K. So in the input, we will be given the number of applicants, number of apartments, and a number K, which is the maximum allowed difference. Cool. Now, let's take this example. Let's say 4 3 5, then we got 60 45 80 60, then 30 60 and 75. So in order to solve this problem optimally, we have to think in the direction of two pointers. So now in brute force way we can do it like we can have two nested for loops that will iterate over each person, like each person desired size, and it will look upon the apartments available, and based on that it can take that apartment. We can go via that approach, but in that the complexity will be big of n square, because we will be not big of n square, it will be big of n times m. Okay. And if you look at the constraint, we are given like n and m are varying between 1 to 2 times 10 to the power 5. So we cannot go via this approach. So the optimal way will be to think in the direction of two pointers. Now, how we can use two pointers is something like this. So we got apartments, and we got the we got the desired sizes, and we got the apartments available. Now if I short this desired sizes, so it will look something like this. Like we got 45, we got 60 60, and we got 80 here. And if I also short this apartments, so here they are already shorted, so let's write it down. Okay. Now if I place a pointer here and a pointer here, okay, and I do the pointer comparisons now. So for this desired size, is this apartment size like fulfilling the requirement or not? So here K is given. So whether 30 belongs to 45 minus 5 to 45 plus 5. No, right? Because it is like 40 to 40, 50, right? And 30 does not belongs here, right? So this will not be given to this. Now, if you look at on the right side, since we have shorted this desired sizes in an increasing order fashion, so if this number is not satisfying this number, so whatever element we have on the right for 45, 30 will not satisfy them also, because if 30 is not fulfilling the minimum requirement here, then whatever number we have on the right, they will be at least 45, right? They will be like more than 45, or like more than or equal to 45, but not smaller than that, right? Because we have shorted them. Now with that, we can get an idea like 30 we can skip, we can move this pointer to 60. Correct. Now when we have 60 here, now we can check whether 60 is satisfying this 45 or not. Okay. Now you can see 60 is not aligning with this. Okay. Now here if you observe, like 60 is kind of bigger than 50, which is the maximum desired size, right? Now, in this kind of scenario, this apartment requirement is not within the bounds of this free apartment, right? So, whatever elements we have on the left of this pointer, or let's say 45, their maximum desired size will not be satisfied with 60, because 60 will always be bigger than that, right? So in that case, we can move this pointer to here, to 60. Okay, and then we can compare the pointers. Now for 60, the like the mean and max will be like 60 minus 5 and 60 plus 5, so it will be like 55 and 65. Cool. Now 60 is within this bound. That means this and this we can assign, like this apartment we can assign to this guy. And once we have done the assignment, so this is done, right? This and this is done. So we can move the pointers to the right. Okay. Now again, the same story will begin. Like we got 60, now the bounded size is like 55 to 65. Now 75 is bigger than the maximum desired size, which basically means we cannot fulfill this guy requirement. So let's look for other guys on the right. So we will shift this pointer to here, to 80. Now for 80, if we check, it will be 80 minus 5 to 80 plus 5. So it's like 75 to 85, right? Now 75 is within this bound, and with that we can assign this apartment to this guy. Okay. Now after this all iteration, we can see like uh there are no guys and apartment left, right? So we are done with the two pointer approach. Now if you think about the time complexity, how we are doing is, so for every person, we are moving the right pointer. Okay, but it's not like we are moving the right pointer again from the beginning, right? So whatever, so from whichever place we are like moving the pointer, we are always going in the forward direction. So we will, so for like 80, I'm not starting from 30, 60, 75. So wherever I left, I'm starting with that. Correct. Now with that in mind, we can say that, so the maximum number of steps we will be taking in this algorithm, it will be the number of applicants plus the number of apartments that we have. So this will be the time complexity, because it is not n times m, because for every applicant we are not starting from like from the zero index again. So we are starting from wherever we left. So we will be maximum doing like m iterations, but we will not be doing that for every n applicant, like for every ith applicant. So yeah, so I hope you understood like how we will approach this problem. So let's code it. Okay. Okay. So we have been given n, m, and k. Now the dimensions for k is like 0 to 10 to the power 9. So it is within integer bound. So we can use int for n, m, and k. Let's take this input. Okay. Now after this, we have been given the desired apartment sizes and the free apartments. So let's create two vectors with let's say desired apartment or desired sizes. Okay, or let's make it d sizes. Okay, and we have been given apartment sizes then, like the free apartments. So let's make them a sizes. Okay, now let's quickly take this input. So for auto le in the sizes, I will be taking this input. Then for auto le in a sizes, oops, I'll be taking this. Cool. Now it will be now we will be shorting our arrays, because without shorting we cannot make all those assumptions that we made here, like on the right we will be neglecting, on the left we will be neglecting. So because of shorting we can make those assumptions. So we'll be shorting both the arrays. So short uh, d sizes begin, d sizes end, then short a sizes begin, a sizes end. Okay, now let's create our answer variable and we will be printing our answer. Now here we will write our two pointer logic. So let's create a pointer that will point to the d size. So let's start with 0, and another pointer for our free apartment sizes. Now we will be running this for loop until pointer, like the d pointer has not reached n and a pointer has not reached m, and we can decide on their uh, like increments later in the for loop. Cool. So let's take the desired size first. So d sizes of d pointer. Now the minimum desired size is this desired size minus k, and the max d size is desired size plus k. Okay. Now the apartment size is a sizes of this a pointer. Now as per our condition, if the minimum d size, okay, like the minimum d size is more than my current apartment size, that means for all the elements on the right of this uh, element, I will for all the candidates, uh, I will not be I cannot assign this apartment, because this apartment is like not satisfying the minimum desired size. So with that I will be skipping this apartment, so I will move my a pointer. Now another condition will be if my max d size is less than my apartment size. Okay, like the maximum desired size, if it is less than my apartment size, then I cannot give any apartment to that guy, because there are no apartments which are like within the bounds of that person, right? So I will be skipping that guy, so I will be incrementing d pointer. This will be else if. Now if these two conditions are not happening, that basically means we can assign the apartment with the current person that we have. So I will be incrementing my answer, I will be moving my d pointer to the next guy, and I will be moving the a pointer to the next apartment. Cool. So I have already taken this input, I can run this code. Cool. So output is 2 and we got 2. Let's submit this. .cpp submit. Cool, it got accepted. Now as per time complexity, let's quickly do the time complexity analysis. Now like I said, so this for loop time complexity is big O of n plus m, but we have the shorting here, right? So the time complexity here will be, if I divide all the complexities, so first is like the big O of size of the d, like let's say like desired sizes. So let's say d is the length, or n is the length. So log of n, and plus big O of m log of m. This is for shorting the apartments. And then we have the for loop time complexity, which is big O of n plus m. So if we take a larger input, this will get dominated by this two time complexity, correct? Now whichever one is max, that will dominate. So between these two, whichever one is like maximum, that will basically dominate the time complexity. So we can simply say the order of our time complexity is big O of max of nm log of max of nm. So this is our time complexity, which is pretty much better than the n times m time complexity that we will have when we are doing this code with a nested for loop. Now for space complexity, so we are not using any other data structure for processing. Whatever inputs we are getting, we are simply sorting them, and there are some only variables acting here. So the space complexity is constant. Cool. So this is the time and space complexity. So I hope you understood the problem statement and the use of two pointers here. And I hope you learned something new. So just stay tuned to watch more videos on CSES.